Hello dear students, welcome back. We will continue chapter number 7, Motion, Force and Work of Standard 7th. This is our third part of the lesson. We learned in the last part distance and displacement, speed and velocity, average velocity and instantaneous velocity, acceleration, force and acceleration. Today, very first topic is Newton's first law of motion. Before we start next topic, let's have a quick revision of what is force and what its effects. See these pictures and examples. Car being pushed by a man, girl pulling a chair. So we can tell push or pull on an object is called a force. Force is due to interaction. See other examples. Force changes the state of motion of a tire, makes it to move faster. Box at rest moves due to force. Then force applied by hands on the dough changes its shape. Force changes the size of a rubber band. So, all these are the effects of force. Means what? Force can change the state of rest or motion of the body. Also, force can change the size or shape of the body. Newton's first law of motion. If no force is acting on a body, its velocity does not change. That is, the body does not accelerate. If a body is in a state of rest, means not moving, it will remain in the state of rest. It will remain as it is. And if it is in the state of motion, it will remain moving in the same direction with the same speed or velocity unless an external force is applied on it. External force means frictional force also we can tell, or any other kind of force. If the body will hit to any object or that collides with a wall, we can tell that is the external force. Here examples given. See, a book lying on a table will remain placed at its place unless it is displaced. Means book will not move. If any force is not applied, it will remain as it is. The book will remain as it is in the state of rest. Ball rolling on a horizontal plane keeps on rolling unless the force of friction between the ball and the plane stops it. See, you will understand in this way. Wait a minute. Newton's first law of motion is called also law of inertia. See in this picture, ball is there. One ball you can see. This, if a body is stationary, it will remain stationary. Means here ball is stationary, not moving. So it will remain stationary. Means it will remain as it is or at rest position. If it is in the motion, if that ball is moving, then it will continue moving with the same velocity and in the same direction. This is the Newton's first law of motion. If Newton's first law of motion, if no force is working on a body, its velocity does not change. That is, the body will not show acceleration. In other words, or simple words, we can tell, if a body is stationary, it will remain stationary. If it is in motion, it will continue moving with the same velocity and in the same direction. If the force acting on the object is 0, then its acceleration also 0. Newton, he explained, if 1 kilogram standard weight is placed on a surface with no friction, means surface is very smooth, plain area, and pull it with an acceleration of 1 meter per second square, then the force applied is called 1 Newton. Okay. So force unit is 1 Newton. Force, displacement and work. In the figure alongside, a string attached to a wooden block on a table is passed over a pulley and tied to a weight. On applying a sufficient weight, the block will be seen to move. Which force is being applied here? Here the gravitational force pulls the weight downward, which leads to a mechanical force that moves the wooden block. How can this force be increased? The force can be increased by hanging more weight on the pulley. What will happen on applying more force? The block will displace more on applying more force. If the block moves forward, we can say that it has been displaced. When can we say that work is done by the applied force? Due to the displacement, we say that the force has done some work. Can we measure this work? Yes, we know that work done depend on the force and the displacement. Always displacement of the body that takes place in the direction of the force. See in this picture that red arrows you can see. In which direction force is applied? Downward direction. Box also will displace or move in that direction, not in the opposite direction. Also, one more thing, more force, more displacement. If more weight, more that wooden block will move forward. So, more displacement. So, more force, more displacement, it means more work done. So, formula we can tell W is equal to force into displacement, means W is equal to F into S. See, the relationship between the force, displacement and work. W is equal to F into S. Here W is equal to work, F is equal to force applied to the body and S is equal to displacement of the body that takes place in the direction of the force. I explained with the help of diagram. In SI system, the unit of work is joule, the unit of force is Newton and the unit of displacement is meter. In CGS system, the unit of work is erg. Energy, the capacity to do work is called energy. Energy is a scalar quantity, means only magnitude is required, no need of direction. The unit of energy in SI system is joule and in CGS system is erg. So, let's have a recap. Vector quantities are displacement, force, velocity and acceleration. Scalar quantities are speed, distance, work and energy.